and he's also a volunteer here at the Adler with our Far Horizons High Altitude Balloon program. So without further ado, I'll bring Dave up and we'll get started. Thanks so much.
Good evening. Welcome to Adler After Dark. I hope you're all pumped about going to space and visiting the outer planets. Excellent. Excellent. Well, it's great to see you all here tonight. Tonight, I'm going to talk a little bit about some of the business opportunities that are happening right now, today. Everything that I'm going to tell you is real. None of this is science fiction. It is happening today. People are working on it. And what we're going to see are some of the interesting opportunities for building businesses that are going to drive our economy into space. But first, before we get started, I have to ask you a question. Are there any rocket scientists in the audience? Hands? One. Excellent. Very good. I'm not a rocket scientist, so it's okay. Let me ask you another question. How many of you want to go to space? Woo! That's a good show of hands. How many of you think it's going to happen in your lifetime? You're a very optimistic audience. Well, I think many of you are actually right on. So, but let's first of all start with the question, why go to space in the first place? Why do we want to do that? And there are a number of reasons. I could tell you that the entire survival of the human race is at stake. 65 million years ago, a large asteroid's orbit intersected with the surface of planet Earth, and the dinosaurs were destroyed. I can assure you the dinosaurs did not have a space program. But I'm not going to talk about that, really. I could tell you that we have to go to space because our planet is running out of resources. This chart shows how much resources we are using today. If everybody on the planet was using up resources at the rate that we are in this country, we would be using up 4.5 planets. That's a lot. So obviously we all can't live that way. If you were living like they do in India, we would be using up half a planet. That's a little more sustainable, but I rather suspect you don't want to live like that. I'm not going to talk about that either. I could tell you that we want to go to space in order to become a multiplanetary species. Elon Musk has famously said that a future in which humanity is a multiplanetary species is a far more interesting and inspiring future than the alternative. I tend to agree. I'm not really going to talk about that either. I could tell you that we need to go to space because space is freaking awesome. And I think that the pictures we got back from Pluto, from the New Horizons mission, or some of the images that we're getting today from Jupiter, from the Juno mission, are evidence that there are some amazing and wonderful things out there just waiting for us to discover them. These are all very good and valid reasons for going to space. But today, we're going to space because space is profitable. I'm glad you got the joke. I was showing my age, and I was afraid that not very many people were going to get that. But the fact is that in order for our civilization to expand into space, it has to be sustainable. And in order for it to be sustainable, we have to have an economy. And an economy that is operating in space, that is making money from operations that are happening in space. And that means building businesses and startups and entrepreneurship that is profitable. So this is what we're going to be talking about today. So it turns out that we use space every day today, right now. How many of you used a GPS to find your way here tonight? How many of you checked the weather on your smartphone before you came? See, you're all using space. You're already using space. These are some of the various applications that are being used today. There are, however, a lot of new applications coming up. Turns out that the space economy is a growth economy. This chart shows over the last about 10 years or so the difference in growth between the space economy and the global economy. And you'll notice that even in the worst year, 2009, when the global economy was contracting, the space economy did not contract. It has been growth every year. I have just a few charts and graphs, and then we'll get back to the pretty pictures. This may be hard for you to see the details. It's not important. The important thing is this is a breakdown of how big the current space economy is. $344 billion last year, and still growing. The other important aspect of this is that all of that stuff up there in brown, that's government spending. The rest of it, 3/4 of the money that's being spent on space, is the commercial private sector. And that's important because that is what's going to drive our economy into space in the future. Investment is following this. This shows how much financing has been happening since 2000. You'll notice that over here on this side, there was an average of 8 investments being made per year in the first 5-6 years of this century. Over here on the left, there's an average of 93 investments being made per year. And that trend is just going up. It will continue. So what's going on? Why is all of this happening now? Well, it turns out that there is a confluence of a number of things. First of all, we've been operating in space for over 50 years. And that knowledge and experience of how to do space is starting to disseminate to a broader audience. In addition to that, we have reduced launch costs. We have off-the-shelf technologies. We have advanced miniaturization and standardization. And all of this is driving the ability to go to space into the hands and into the reach of startups and entrepreneurs. So let's go back and look at some history for a moment. How many of you remember the space shuttle? Yeah, that's good. Unfortunately, the space shuttle ended in 2011. And many people thought that the space program was over at that point. That's not true. In fact, NASA made a very important decision. They created the Commercial Orbital Transportation Services Program. And what this said was that NASA was not going to try to build its own rockets, although they are, and that's another story. They were not going to buy, they were instead going to buy launch services from commercial providers. This is a new thing. Nobody had done that before. But it was a very important decision because what it did was it opened up a vast market for launch services. And that has driven this boom in the space economy that is happening now. So there are a number of commercial launch providers. SpaceX is probably the most well-known. United Launch Alliance is a joint venture between Boeing and ULA, and Orbital ATK. Those are the US launch providers. Arianespace is the company that is providing launches for the European Space Agency. Of course, Russia is launching the Soyuz rocket and, or Soyuz space capsule, actually. That's how we're getting to the space station these days. And India, surprisingly, is also become a major player in the launch services market. The Indian Space Research Organization has launched a number of private satellites into space, and they're doing it very cost effectively. So there's some folks to watch. In addition to that, there are a number of new launchers that are under development. And this is very important because this is going to provide diversity in the launch market. And as people are exploring different ways of getting to space, we're going to find cheaper, faster, and more robust ways to get there. Some of these companies you may recognize. Blue Origin, this is Jeff Bezos' company. He's been in the news recently. You probably recognize Virgin Galactic also. That's Richard Branson's company. But some of these others are exploring other interesting ways of getting to space. Pictured here is the Sierra Nevada Dream Chaser. It looks kind of like the space shuttle. It's designed to fit on top of a rocket, launch into space, and then fly back down to the ground. Still under development, but we expect to see that flying within a year or two. Some of these others are exploring ways of launching small payloads into space in a very cost-effective way. And we'll see that that's important in a few minutes as well. One of the things that's happening is that the cost of launches is coming way down. So in the shuttle era, it cost $1.5 billion per launch. That's an enormous amount of money, and that is one of the reasons why people claim that space is too expensive. Well, some of these some of the launchers operating today, Orbital ATK, ULA, they cost somewhere in the range of $220, $250 million per launch. Still expensive, but not nearly as much as the space shuttle. But check out SpaceX. To launch a Falcon 9, it costs $62 million. That's unheard of. That is cheap compared to $1.5 billion. And that price is only going to come down. Why is that happening? Well, I used to say this was an image of a very rare object. This is a rocket that had flown to space and come back down and launched again. When I first started giving this presentation, that had only happened once or twice, about 2 years ago. In the intervening 2 years, that has happened numerous times. And in fact, SpaceX has now launched 20 as of this past weekend, rockets to space and brought them back down to the ground successfully. In addition to that, they've reflown 4. And also on this mission this past weekend, they launched a Dragon capsule, which had flown to space before, again. So that capsule has flown now multiple times. And this is important. Imagine if you flew from Chicago to LA, and when you got to LA, you took your airplane and you dumped it in the ocean. How expensive would that be? Okay? So being able to reuse your spacecraft is very important because then the cost per launch comes way down. So SpaceX is well on the way to getting there. And from my perspective, the problem of getting to space is solved. And so the business opportunities now are going to be what happens after you get to space. What are we going to do once we're there? Well, one of the places we can go is the International Space Station. And in 2005, Congress declared that the US portion of the space station would be an international laboratory open to scientific, academic, and commercial interests to do research in space. That last one is very important because what it means is that if you have a company and you want to test out something in space, you can get it on the space station. And it actually won't be that expensive to do it. So this is a huge incentive to make things happen. One of the ways that you can get there is through the Center for the Advancement of Science in Space. CASIS is an NGO chartered by Congress to get experiments and research onto the space station. Now they're focused in these 5 areas: life sciences, material sciences, physical sciences, technology development, and Earth observation. Those have been the backbone of the space industry until now. But as we'll see, there's some new things coming up that are going to be very interesting. So CASIS is an NGO, but there's also a commercial providers. NanoRacks, founded in 2009, they were the first commercial operator on the space station, and their mission is to get your experiments into space. Charge you a fee for it, of course, but they'll do it cost effectively. The advantage is that you give them the experiment, they will take care of the mound of paperwork that NASA requires you to go through. They'll find you a launch opportunity to get it there. And then on station, they have racks you can put your experiment into, standard racks. So if you conform to that standard interface, then it's very easy to get something there. They also provide mechanisms for launching small satellites, and you see that here, being launched from the space station. And so if you have a small satellite, and I'll talk about that in a minute, they will get it into space for you. So small satellites are a very important revolution. They are, in the past, if you were going to create a communication satellite and put it in geosynchronous orbit, it would probably cost $2 or $3 billion. It would take 5-6 years to make it happen. You're going to design that in order to last for 20 years, 30 years, which means that it has to be extremely robust and extremely reliable. You don't want that bird to fail halfway through its lifetime because that's an enormous cost down the drain. The advent of nanosatellites changes that equation because now we can try something, put it into orbit, and if it fails, no big deal. It's not that expensive. We'll get another one next month. And this is causing a revolution in how we put stuff in space and what we can do in space. So here's an example. Planet is perhaps the poster child for this next space economy. They are in the Earth observation business, and their goal is to image the entire surface of the planet once a day. Okay, that's revolutionary. We have not been able to do that. Now, how are they able to do this? They're flying a fleet of spacecraft that they call doves. They are The previous photo actually was an image of a dove. The satellite is about this big. Okay, and the reason why this is possible is because of the advances in technology. If you think about the amount of capabilities in your cell phone, this small device has more capability than a lot of the things that have been flying up there because they were designed from technology that was 20 years old. And so by being able to fly something rapidly, get it up there, and try things out and be willing to fail, we can advance our capabilities very rapidly. Here's another example. Spire. They're in the maritime observation business. Again, some small satellites observing ships that are traveling across the ocean. Nobody's been able to do this before. It's not possible to know where your ship was, where it was going, and what was happening to it. They're also doing some weather observation. They're collecting weather data as well. So that's the nanosatellite revolution, but there are other things that we can do as well. Space-scalable is one of the big opportunities. Space-scalable means developing an application for something here on Earth, making a profit doing that. But that application can also be scaled to solve key problems in space. And so this is the reverse of a space spin-out. Sometimes we call it a space spin-in. It's technologies that we're developing here for solutions here that can be then used in space. So let's look at some examples. Space VR. They are taking virtual reality to space and bringing the experience of space back to you. So they've put a VR camera on the space station, and they're going to be just observing that and then bringing that experience so that you can put on a VR helmet and feel like you're in space, obviously with the intention of allowing you to know what it's like up there. Here's another one. Nanoli is a biotech company. They have developed a polymer that will preserve vaccines and other medicines without refrigeration. Think about that for a moment. It has huge applications. In emergency response situations where I have no power, I don't want my vaccines or other medicines going bad because there's no refrigeration. Or perhaps the military is operating in the desert. Again, no power, it's very hot, I don't want my medicines to go bad. This also has application in space because if I am going to be spending a long time either on the space station or in a deep space spacecraft, for example, I want to bring medical supplies with me. And if I have to refrigerate those medical supplies, that uses power. That adds to my power budget, and that makes my spacecraft more expensive. If I can eliminate that cost, then that is a huge advantage. So what else can we do? Made in Space is developing manufacturing capabilities on the space station. They developed the first 3D printer that has flown in space. You see here astronaut holding a 3D printed ratchet. That was the first object that has been taken to space or that has been used in space that did not fly on a rocket. Yeah, the raw materials went up on a rocket, but it was actually manufactured in space. And this is going to be a huge revolution. If I don't have to design something to withstand the rigors of launch, doesn't have to put up with being vibrated for 10 minutes and experiencing the massive G-forces, that really opens up things that I can do. In addition to that, we can start to build much larger structures, much more delicate structures in space. Made in Space is also prototyping a technology to create an optical fiber called Z-bland. Now, the significance of this is that Z-bland is a very high efficiency fiber. It lets you pump a lot more data more effectively. It's much better than normal optical fibers. But Z-bland is very difficult to make in a gravitational field. The crystals don't form the way that you'd like them to. So they found that they can take this to space. They have a mechanism that will draw the fibers in space in a microgravity environment, and it comes out really good. So they can then send the raw materials up, draw the fibers, and bring it back down to the ground more cheaply than it would cost to make that same fiber on the ground. So they have found a significant business opportunity and a significant application for manufacturing things in space. Acme Advanced Materials is a similar company. They have an advanced power electronic systems that, again, can be made in a microgravity environment. Interesting thing, the CEO of Acme Advanced Materials said that touting orbital manufacturing at this point was not necessarily a plus because people were like, oh, isn't that complicated? Doesn't that make it expensive? So they just call it advanced manufacturing. But they have found that they can make these power electronics profitably by going to space, creating the semiconductors in that microgravity environment and bringing it back down to the ground. So this is the first step of a true space economy where things are being made in space, to be used in space, or to be brought back down to the ground. So all of this activity that's happening is going to require more space in space. The International Space Station is actually quite crowded. And so there are companies that are working on building modules that will be used for commercial space stations. So once the International Space Station has reached its end of life, which will be happening within 10 years, we're going to need a replacement. And so these commercial space station operators are building the technologies for us. Bigelow Aerospace has created a technology which allows you to expand a module. So you can send it up in a compact way, get it on station, and expand, and it gives you a large volume that can be used. Bigelow was founded by Bob Bigelow, who's the owner of Budget Suite Hotels. And so I'm expecting that once they've finished prototyping this, and by the way, the Bigelow Expandable Activity Module, which is what we see up here, has been on station for over a year, and NASA was testing it and just recently qualified it for use by the astronauts. So it's now going to stay on station, and they're going to have it as additional space on station. But Bigelow is planning some larger modules for a commercial space station. So I'm expecting to see the budget suites in space real soon now. So far we've been talking about activities in low Earth orbit, and it's kind of a shame, but we have not gone beyond low Earth orbit in the past 40 years. So where are the other places that we can go? This plot, I really love this plot. This shows all of the minor planets in the solar system. Well, actually, it's in the inner solar system. There are over 685,000 known minor planets in the entire solar system. So what we see here is the Sun, then the first circle is the orbit of Mercury, orbit of Venus, orbit of Earth, orbit of Mars, and then this big circle is the orbit of Jupiter. All of the green dots here are main belt asteroids. The important ones are the red dots, because those are Earth-crossing asteroids. Their orbits bring them across the orbit of Earth, and that means that they're fairly accessible. So it turns out there's a lot of places we can go. Let's break this down a little bit. This is the Earth-Moon system, and it shows some of the most common places that we'll want to go, starting with low Earth orbit, that's the inner circle around the Earth, then geosynchronous orbit, that's the outer circle. Then next is what we call Earth-Moon L1. It's a gravitationally stable point between the Earth and the Moon, and it is a prime real estate for building a space station. And in fact, NASA recently was talking about building the Deep Space Gateway as part of the new redirected NASA mission to the Moon. The Deep Space Gateway will probably go to Earth-Moon L1. And then, of course, the surface of the Moon. The other thing that's very important is the near-Earth object up there at the top. There are thousands of asteroids that are actually energetically closer than the surface of the Moon. Why is this important? Because those are resources. So here is the slide I'm sure you've all been waiting for, asteroid mining. I love this infographic from Planetary Resources, and it's all about how we're going to make a $1 trillion economy by mining resources from asteroids and so forth. And people usually talk about mining platinum or other rare earth elements and bringing that back down to the ground. That's all well and good. The important thing, actually, is this: water. In space, water is the most important resource. Water is air. Water is water. Water is life. But it's also fuel. And if we can make rocket fuel from water, all you got to do is catalyze it, and you get hydrogen and oxygen, and you're good to go. If we can get that rocket fuel from space, then we don't have to boost it up from the ground. It will be cheaper to use it up there. And what that does is it opens up the entire possibility of spacecraft that can refuel themselves in space. We don't have to bring all of that propellant from the ground. If you look at one of those big rockets, most of that volume in that rocket is propellant. So most of what the rocket has to do is lift the weight of the propellant to get into space. If we don't have to do that, we can use the propellant that's already up there. That really opens things up a lot. So there are people working on this, a company called Deep Space Industries, and also Planetary Resources. They are right now developing technologies to prospect asteroids for resources. They're going to be looking for water. One of the other places that we're going to be looking for water is on the surface of the moon. Both of them are prime targets to get resources. And then they want to also extract other resources from the moon, from the asteroids as well. And that will, again, start to boot up the space manufacturing economy that I was talking about earlier. So once we have resources coming from space and manufacturing happening in space, and the output of that manufacturing going to building habitats in space, building deep space exploration spacecraft, and so forth, then we start to have an economy that's happening in space. And that is what's going to drive our civilization to settle the solar system. So let me leave you with this. Space is not a program. Space is a place. And because it is a place, the people who go to that place will do the same things that people who inhabit any place do. They will have to make that place habitable for life and for expanding civilization. The challenges of space are familiar: air, food, water, energy, habitats, transportation, resource extraction, manufacturing, entertainment, communications, vacations, space tourism. There are 1,000 hard problems that we need to solve in order to settle space. Each one of them is a business opportunity. And I want each and every one of you to think about the problems that you are solving today and how they can be applied to drive our economy into space tomorrow. So here's the commercial. I'm, in addition to the CEO of Orbital Transports, I'm also the founder of NewSpace Chicago. And NewSpace Chicago is a networking community of space entrepreneurs, experts, investors, and other people who are interested in building companies that will go to space that are located here in Chicago. We believe that Chicago is well positioned to become a player in space. When you typically think about the space industry, you go, oh, Florida, Southern California, Texas. But if you think about what's happening there, you're talking about the launch industry. You're talking about people building communication satellites mostly, or Earth observation satellites, the big old legacy satellites. Or you're talking about the defense and airplane business. But as we've been talking about, there's a whole opportunity for manufacturing in space and other activities. And Chicago is well positioned to be a center of excellence for this coming next space economy. We're an old manufacturing town. We still have a vibrant manufacturing economy. We're a national transportation hub. If you're going to transport anything in this country, it's probably going to go through Chicago. We have world-class universities and research institutions. We have a highly trained and motivated technical workforce, and we're a global financial center. All of these elements can be brought together to create the businesses that will take us to space. So NewSpace Chicago is focused on making this happen. We have networking events on a monthly basis. Our next event is going to be in January, located at the M-Hub Chicago Manufacturing Innovation Center. And our speaker at that event is going to be a person from Boeing Horizon X, which is the Boeing venture capital arm that is interested in promoting space businesses. So if you're interested in what I've been talking about tonight, if you think you might have an idea that could turn into a space business, or if you're interested in being involved in space businesses, check out NewSpace Chicago.